Here's an update on the 630TS project. I'm now working down in this area, which I suspect will be the most challenging. That's where we got 4 can electrolytics. I already took out the little guy. That was fairly easy. That was up here. And now I'm working on this guy. I think I got all the wires off now, and I'll try to straighten out the twist lock tabs, and then hopefully that's enough clearance that I can pop it out and extract it. And then there's 2 more down in here. Now, one of the challenges I've been finding in this set is that the wiring is really stiff, really crunchy. These wires just do not want to bend, or if you try to bend them, what'll happen is they crack. Well, I read a tip online, I think on the Antique Radio Forum, about heating up the wires. That seemed a little crazy at first, but when I examined these more closely and see how it was black on the end there, I thought that was the outer cloth coating charring when I was heating these up with a soldering iron. But no, it's not what's happening. It's actually the inner substance, which is kind of like tar. Maybe it is tar, I'm not sure. So it's not just wire with cloth wrapped around it. There's something in between the wire and the cloth, and that's what's rock hard. So, for example, this wire right now, it doesn't want to bend at all. And if I push down on this any harder, it's just going to crack the cloth coating and the goo underneath it. So, check this out. Speed it up a little bit. And you can see it visibly starting to wilt as it heats up. And now, at least for a little while, it's nice and pliable. And whatever shape I bend it in, as it cools off, it's going to stay like that. So, just a little tip for you. Unfortunately, it doesn't restore flexibility permanently. So this is already starting to get harder. But, you know, at least it's a help. So if you need to move an area of wires, just kind of heat up that whole area, push the wires aside, do your work, and then maybe heat them up again and kind of push them back to where they go. Otherwise, you end up cracking them like I did on this rather heavy wire. There's a kink down in here where you see that cracked. So I may want to slide a little bit of heat shrink tubing over that or something. Otherwise, you could risk exposing some of the inner stranded wiring if you really crack it badly. I've been making pretty steady progress and have finished with this whole area up here. No surprises so far. Now I'm working up in this area, and I'm going to go with modern components that are not stuffed inside of old components, at least for now. Because what I found up there were these guys. 0.01 microfarad caps going right to the AC input to the chassis. Those are these guys in the schematic. Those are line filter caps. These tend to go bang as they fail internally and then shatter the Bakelite shells that they're inside of. And here's what I'm going to be using, which is proper modern safety caps. Type X1 or Y2, meaning that you can use them both across the AC line or either side of the AC line to ground. Now, I suppose these are small enough that they just might fit inside. I don't know, they might be a little bit too large in diameter. And I suppose I might as well see if I can split one of these open, because I never have before. I'm kind of curious to see, A, if they can be split open, and B, how much room there is inside once you scoop the guts out. But for the sake of safety, I'd rather go with these, even if they are visible, rather than leaving these in or not using them at all. I do tend to have noisy AC lines around here, as you've seen some of my earlier radio projects, so I really do think it's a good idea to put those in there. Now, another case where I'm going to be using a modern component is to replace this guy, which I suspect is not the original anyways. It's supposed to be a 5,000 ohm 5-watt resistor up in this area, but this is what they call a dog bone resistor. They use these in the 30s. I think by 46 they would have been using something a little more modern. In fact, if you recall, inside this metal enclosure. There were some more, well, I don't know if it's called modern, but more modern looking than this. These would be wire wound power resistors covered in ceramic, or on a ceramic core and then enameled, rather than this, which I believe is just a giant carbon composition resistor. It's only measuring about 2,500 ohms, so it's got to go. And here's what I'm going to be using for now. It's an ohmite vitreous enamel, 5 watt, 5,000 ohm resistor. Quite a bit smaller than the original guy. Well, or the one, I should say, the one that was in there. I don't know. I haven't found any good photos of original chassis online. And I think in my other 630 TS, it had been replaced with something as well. So maybe that was a common point of failure. But you know, I'm just not sure what originally would have been in there. Perhaps this is the original. I don't know. Let's see. I'll take a closer look at where it was attached. It's going from here over to this point. And I just can't tell if it was replaced or not. It's certainly not an obvious, like, really loose or bad solder joint or anything. So I don't know. Yeah, whatever. For now, I'll go with this. It's pretty darn small and kind of inconspicuous looking, anyways. Here's a peek underneath my other RCA 630 TS, and there's that same resistor, and it's very different looking in this set. But I'm also not sure if this is an original or not. If it is, well, you can see it's quite a bit different. It's flat, ceramic looking package. I'm currently working on opening up another electrolytic capacitor, and I thought you might like to see how I go about doing that. I've got myself a set of jeweler's screwdrivers, flat-bladed variety. So basically, very small, sharp blades. And I first started out by working the smallest one just underneath the lip. We just get a little bit of a purchase. I've also done the same with pocket knife, but in this case, because we've got all these prongs sticking up, it's kind of hard to get anything larger and threaded in between them. Once I got it lifted up just a little bit, I switched to a larger screwdriver and just kind of used my hands and worked it in there until I got to the point where I could just pry it up a little. And now I'm switching to actually tapping it just with an old pair of wire cutters and just kind of walking it around, tapping it lightly along the seams. So what that's doing is it's wedging the screwdriver in between the aluminum and the metal ring. You can pry it up a little bit, a little more tapping, a little more prying, and slowly work your way all around. You can just pop that ring right out. And then I heat up the can, heats up the tar at the bottom, and you can pull the insides out. A little tedious for sure, but not too bad once you get the hang of it. Some are definitely easier than others. This one is fairly easy. Seems the easier ones is when they have a larger bit of aluminum folded over. Some of them it's more tightly curled and you don't get this big flat area. And those those can be a pain. In fact, you can see here are the rings. So this one was fairly easy. Very similar to the one I'm doing now. This one, not so much. And you can see the difference in the gouges in the steel on this, the one that was tough. I do it in very small increments. Just tap, 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 tap all the way around the ring. Whereas this one was more like the one now, where I could, a couple taps would pry up a larger section, so I could, fewer steps to get around the ring. And there's the glob of tar at the end that was holding it in. Well, just wait for that to cool down. In case you were wondering about the conditions inside this capacitor, well, just like the one I did earlier, this one's pretty bad too. And so there are multiple sections in this can, meaning there are actually 3 capacitors in here. Well, here's the outermost one. Definitely signs of deterioration. Can't tell if it completely blew through, although it does look like it here, now that I take a closer look. And then I kept unraveling, and after a section that looked pretty clean, I got to this. Well, there sure looks to be another blowout on this one as well. So, as I said before, I really don't see the point in trying to reform capacitors that are this old. They deteriorate over time, the electrolyte chemically breaks down, and they dry out, so just put new caps in. Now, as for cleaning out the old tar residue from inside the can, well, previously I'd been using naphtha. The odor isn't too bad, and it evaporates fairly quickly. But I was running low on that, so I searched around to see what else I had on hand, and I found that I had a nearly full can of pure gum spirits of turpentine, which turns out works just as well, if not better, than the naphtha. And it has kind of a nice pine smell to it, so that's what I'm going with right now. Here's a can I just cleaned out. I just pour a little bit of the spirits in there, slosh it around with a glue brush, let it sit for a while, and pour it out, maybe do a couple passes, and then finally wipe it out with a paper towel. I just finished installing new caps in the last of the electrolytics. That was this guy. So now I will reassemble them, remount them in the chassis, and start rewiring them back in. This is another one of those that had a cardboard cover over it, so I just cut it open near the base, and I'll just slide a new cardboard sleeve over it. The others, though, I want to recrimp. Here's one I'm working on right now, so what I do is seat this back in. Sometimes I use a little bit of hot glue, too, if the caps are kind of flopping around, so they don't rattle around inside the can. So get that seated down in there, put the metal ring on, hopefully it's salvageable. If these tabs break off, I'll grab another can, if possible, that has the same diameter and spacing, and get the ring out of that one. In other words, when I have scrap chassis, parts chassis, I'll salvage electrolytics just for the rings. Anyways, get that seated down in there, and then I start bending, crimping the aluminum over. I just use something like basically a hard steel rod, like in this case just a screwdriver, and just kind of hold it in one hand and push against it with this, and kind of push around and slowly mush that over until it's like this, and then I'll use a small hammer and kind of tap that around to smooth it all out, and then it's pretty unnoticeable. And then finally, I suppose, since I've got them out, I'll take some metal polish and clean them up a bit. This one doesn't look too bad, but some of them have this yellowy coating that was common to the whole chassis, if you recall. In an earlier segment I was cleaning it off, so for example here it's been cleaned, but in an area like this you can see how yellowy it is. I don't know if that's just from age or it's nicotine from heavy smokers, I don't know, but I do know that it comes off fairly easily. Here are some of the completed rebuilt caps. Just the end resealed, and then I polished them up with some Simichrome, and they came out pretty nice. So now I will have the challenge of reinstalling them, but before I do, I'm going to do all the paper caps. I've already finished up till here at the section left. I think this is going to be the most interesting. I was just perusing Phil Nelson's restoration site again, and he mentioned how congested this area is, and yeah, I can sure see what he means. There's several layers of capacitors, so I'm going to have to remove them down to the deepest one back in there, and then start working my way back out. I was having a very difficult time getting down into this corner to work on, so I ended up unmounting the volume control and power switch. I left as much connected as I could to make it easier to put back in. Now while working down in here, I discovered a resistor, supposed to be 330K. It's actually measuring about 10 times what it's supposed to be. So I'm glad I opened this up so I was really able to get in there and properly test everything. And here's one of the caps that's been restuffed, ready to go back in. It goes way down in there, so I'm going to start working the farthest point back and then work my way back out and eventually replace the control. And that will be it as far as the paper caps go. I finished all the rest of the setup into here. It's just this little cluster down here. Then I still have the electrolytics to remount, and that'll be it. And then time to, well, so say time to power it up, but I'm really a little nervous about this because I've done so much work to it. So one thing I'm going to do before I try powering it up is get the resistance chart. I don't think it's in the RCA service info, but I'm pretty sure it's in the SAMs, and that shows you what the resistance between the chassis and each tube pin should be. So I'll go through with my ohm meter. Oh, and by the way, I do have a new Fluke multimeter. I'll talk about that in an upcoming video. I'll go through and check every socket, especially when I check the power supply stuff. At least it'll give me a little bit of confidence that I haven't screwed anything up. Well, when I still need to check the field coil on the speaker, you know, we saw those caps that were pretty bad, pretty sorry shape. Looked like they had been shorted out, and the big dropper resistor was fried. Some of these guys are bleeder resistors, which may indicate that the cap shorting put excessive load on the resistors and burned them out. Well, it might have also taken out the fuel coil. Oh, I'm trying to find where it is on here. Could this be a permanent magnet speaker? Huh. No, that's definitely a fuel coil right there. Traced out the wiring. It goes through a hole right down in there and goes over to here, which goes over to the filter caps. I looked at the schematic again, and there it is. Should be 62 ohms, so I'll check that right now. Let's see, so one side, and here's the other. Alright, so it's supposed to be 62 ohms, I got 58. That's close enough. Good. One less thing to worry about. After I finished recapping that area, I remounted the volume control, reinstalled this audio IF shield, and then remounted all the electrolytics, and I'm just about done wiring them back in. I've got a little bit more to do down in here. And I have been double and triple checking all my work as best I can. Once I get those last few wires connected, I will do what I mentioned earlier, which is go through this resistance chart, which I did find in the SAMs. So for all 30 tubes, they show the resistance that you should get on every pin between the chassis, generally speaking, and a few cases where they have asterisks. They go to pin 8 of V28, which is one of the 5V4 rectifiers. So I will take care of that tomorrow and then try firing it set up for the first time. So stay tuned for that in the next installment.